Okay, the last part of the fundamental theorem of calculus, 5.3, we just have two problems to do. In number 5, it tells us that the velocity function v of t in meters per second is given for a particle moving along a line. Find A, the displacement, and B, the distance traveled by the particle during the given time interval. Okay, this is key. Displacement is this. If I go to the store, if I tell my kid, hey, go to the store for me and come back. If she starts at home and she goes to the store and she comes back, if she ends where she started, the displacement is 0. She is where she began. Displacement is how far away you are at the end from where you were started. So, but we know that she traveled much further than that. She drove the store that far. She drove back to the store from the store. So she traveled here, plus she traveled here. So that is distance. So when they ask for displacement, this is a straight up integration. When they ask for distance, you have to negate the negatives to make them positive. So think about that. Here we go. This is our function velocity. When they want distance, that is position. They gave me velocity, which is the derivative of position. I have to find the antiderivative or integrate to find the distance traveled, or the displacement. So let's do that. The displacement from this time period is simply the integral from 2 to 4 of t squared minus 2t minus 3 dt. Here's what I want you to recall, that, okay, if the derivative, if we have some position, this says how far something moves, the derivative of this is what velocity is, right? And the second derivative of this is the first derivative of this is acceleration. So we can integrate acceleration to get velocity, and we can integrate velocity back to get position. So that's how those functions relate. So right here we're integrating velocity to try to get position, and we're going to find the displacement. This is what this is going to give us. Let's integrate this. This is going to be 1/3 t cubed minus 2t squared over 2 minus 3t. We would say plus a constant, but it's a definite integral, so we're going to evaluate this from 2 to 4. Now we evaluate this with the 4s. 1/3 t times 4 cubed minus, the 2's will cancel, 4 squared minus 3 times 4. We're going to subtract this with 2, 1/3, 2 cubed minus 2 squared minus 3 times 2. And you can calculate this and this, and I'm not going to take all that time to do that right now. What I'm going to tell you, it ends up being 2/3. And what does this mean? This means that this particle ended up 2/3 of a meter away from where it started. That is not the distance it traveled. Let's calculate the distance. How could we set this up? Well, let's look at the velocity function, okay? Where is this guy positive and where is this guy negative? This is the equation of a parabola. Let's think about that. Here's a parabola. Let's graph it. What are his zeros? Let's see. T squared minus 2t minus 3. Where does this guy equal 0? T minus 3, t plus 1, t squared minus 2t minus 3. We could factor it and find the zeros. T is at 3. T is negative 1. Oops, negative 1. All right. So here's negative 1, and here's 1, 2, 3. Here's 3. And so here's some parabola. Oop, that's not right. What's wrong about that? What's wrong about that? I hope you guys are saying it at home. What's wrong about that is that this has a positive leading coefficient, so this is going to be facing up. This looks better. This is going to be some parabola like this. All right. Now, where are we supposed to integrate this from? We're supposed to integrate it from 2 to 4. So let's look at this. Here is 2, and here is 4. All right. This is 2. From 2 to 3, this guy is negative. And from 3 to 4, it's positive. So we need to split up our integral if we want to find distance. This is how we'd set this up. Let's integrate from 2 to 3, but we're going to take the negative of it. So that's going to be t squared minus 2t minus 3 dt plus, we're going to integrate from 3 to 4, t squared minus 2t minus 3 dt. And so we would integrate this. Let's see. Let's be careful here. I'll set up the numbers. This is going to be 1/3 t cubed minus 2t squared divided by 2 is minus t squared minus 3t, the negative of this, from 2 to 3. However, if I don't want to do from 2 to 3, if I want to take care of this negative, here's another thing I could do. I could switch the limits because there is a limit. I mean, there's the integral rule that says we could do that. So I'm going to do it that way. And so it's upper minus lower. So I'm going to plug in the 2 first and subtract it from the 3. Plus 1/3 t cubed minus t squared minus 3t from 3 to 4. So we would plug in all these numbers with 2. T is 2. We'd subtract that. Plug in all the numbers for t is 3. We would add that to plug in all the numbers here for t is 4. And we would subtract that. Plug in all the numbers for t is 3. We'd add all that together, and this is what we get. We get 4 meters. So although the particle ended up just 2/3 of a meter away from where it started, the total amount that it traveled between 2 and 3 seconds was 4 meters. Okay, that's that one. Here's the last one we have to do. Here we go. The acceleration function in meters per second squared and the initial velocity are given for a particle moving along a line. Find A, the velocity at time t, and B, the distance traveled during the given time. And they give us the acceleration. Here we go. Acceleration. You got to remember how these guys relate. Acceleration, velocity, and position. So let's start with what they gave us here. Okay. Number 6. They told us the acceleration function is 2t plus 3. A of t is 2t plus 3. And they give us the initial velocity, v of 0, is equal to -4. And they want it between 0 and 3 seconds, right? Yeah. All right. So it says find A, the velocity at time t. How can we find velocity? Well, we're given acceleration, so we need to take an antiderivative because this is the derivative of velocity. So let's do that. Let's find, let's integrate the acceleration. Okay, let's do that. So let's say the integral of 2t plus 3 dt. So that is going to be 2t squared over 2 plus 3t plus a constant, right? But this is what velocity is. And 2 over 2 is 1, so this is just t squared. T squared. And they told us this initial condition, which says that when t is 0, v of 0, that's equal to -4, and that's equal to 0 squared plus 3 times 0 plus c. And so we find out that c is -4. So the velocity function, part A, is equal to t squared plus 3t minus 4, because that's what c is. All right, cool. This is a velocity function. The last thing we have to do is find not the displacement, but the distance. That means we have to think about where is it positive and where is it negative. So, again, this is a parabola facing up. Where are its zeros? Let's figure that out. I think this factors plus 4 minus 1. Let's see, t squared, 3 minus 4. Okay, so we find that t is -4 and that t is 1. -4, -3, -2, -1, 1. So here, and this guy is facing up. All right, that's fine. Where are we integrating? We're interested between 0 and 3. Here is 0, here is 1, here is 2, here is 3. So after 1, he's positive, right? He's always positive after this guy. He's positive. Before 1, he's negative, and over here, he's positive. That means we have to negate the negative. So we're going to split our integral up. We're going to first integrate from 0 to 1. I want the negative of this. T squared plus 3t minus 4 dt. And then I'm going to add from 1 to 3, because it's positive from there. T squared plus 3t minus 4 dt. All right, we can leave that negative in there, or you can switch the limits. That's also allowed. So let's integrate. This is 1/3 t squared plus 3/2, 1/3 t cubed, thank you, plus 3/2 t squared minus 4t from 0 to 1. It's upper limit minus lower limit, plus 1/3 t cubed plus 3/2 t squared minus 4t from 1 to 3. We will plug in all of our numbers where t is 0, and we will subtract all of our numbers where t is 1, and then we'll add this to all of our numbers where t is 3, and then we will subtract all of our numbers where t is 1. And if you do all of that, you find that you get the total distance is equal to 89/6 meters, or in decimal 14.83 meters. All right, that is the fundamental theorem.